Hello, my friends. Why do skeletons never go trick-or-treating? Because they have no body to go with. In this video, you're expected to go through your Lesson 3 slides and check your answers with my explanations and make sure you have everything understood completely. You shouldn't be watching this video until you have finished filling out the slides for the first time. So first we've got a bunch of vocabulary that we're going to keep coming back to, and I'll reference back to this slide several times throughout the video, but this is different ways we can relate numbers. Ordered pairs, equations, verbal, mapping, graph, and table. To answer the question whether this table is a function, we have to look at all of the inputs and make sure that for every input there is only one output. Since -1 only shows up here, there's only one output. Since 2 only shows up here, there's only one output. If we would have seen another -1 further down in the table, something like this, we wouldn't have a function anymore because -1 would point to two different numbers. It would point to 1 and 7. That doesn't happen in this table with any of the input values. 5 only points to one thing, 6 only points to one thing, and 7 only points to one thing. Therefore, this is a function because every input points to one output, only one output. Next, we're going to look at a mapping and see if this mapping looks like a function. Remember, a function says every input gets paired off with exactly one output. For instance, 1 gets paired off with 2. So far, so good. 2 only points at 0. So that's good. But the input 4 points to two different numbers, 5 and -5. That breaks the rule of being a function because every input can only have one output when dealing with functions. So we're going to say, no, this is not a function because one of the inputs points to two outputs. This one was a little trickier. We have to see if this verbal relation is a function or not. So it says a relationship between students in your school and each student's birthday. So we've got a bunch of students. Let's say we've got students A, B, C, and D. Since it's not possible for one person to have two birthdays, then it sounds like this is going to work out because you can only have one birthday. Every single person has one birthday. Two people might have the same birthday. That's definitely possible. But that's still a function because every input has one output. It doesn't matter if 15 different people have a birthday on January 3rd. The important detail for a function is every input, so every student has one output. Every student has one birthday. If we magically had someone who was born on 2 different days, then we would say that this was not a function. But nobody was born on 2 different days, so this is a function. In this scenario, we've got a function defined where C is representing the cost of shirts and S is the number of shirts. So input is going to be whatever we need to know first. So you need to know the number of shirts before the cost of the shirts. So the domain is going to be that input, the number of shirts. And then once you know the number of shirts, your output, or your range, is going to be the cost of the shirts. This question's a little tricky. Describe the possible domain and range of this situation. Well, we can have as many shirts as we want, starting with 0, ending at, who knows, infinity. However, we can't just choose any number. We can't have -7 shirts. We can't have 3.5 shirts. So when we're talking about possible domain here, we should technically say something like any whole number or any integer bigger than or equal to 0. So you could say something like that. That would kind of get the idea across. You have to have whole numbers, including 0. You can't have negatives, can't have decimals. You don't buy half of a shirt. Range is a little tricky too. Even if you have 0 shirts, you still have a cost. We have that overhead cost of $15. So that's one input. That's the smallest input we could possibly have, because now we start buying shirts. If we bought one shirt, we'd have 15 plus 8, so 23. Then we could add 8 again. Add 8 again. So there's no way the cost would be something like $40, because to get 40, we would need to have a decimal or a fraction number of shirts. It's not going to happen. So our range, or our outputs, all these numbers, it goes on forever, starts at 15, keep adding 8. I'd call this more of an advanced question. Don't freak out if this one seemed hard to you during class. How can you determine if a relation represented as an ordered pair is a function? Explain your reasoning. I'm looking for some kind of full sentence explanation here, something about how every input has to have one output. No matter what representation you're looking at of a relation, in order for this relation to be a function, you need every input to have one and only one output. Just as a quick example, if I start listing some points here, so far this is a function because I have every input has exactly one output. Even if the outputs are the same on two different ordered pairs, that's okay. It doesn't say every output has one input. Every input, which is the x value, has one output. I could mess this up and not be a function anymore if I chose 2, 5, let's say, because then I have 2 as my input 2 different times, and they do not have the same output. So if I just keep the blue, that's a function. As soon as I add this last ordered pair, 2, 5, that's not a function. Again, you should be writing a sentence saying something about how, for a function, every input has to go to one and only one output. How can you determine if a relation represented as an equation is a function? Explain your reasoning. Well, my equation is going to be y equals something. And pretty much anything we've ever seen with y equals something has been a function. No matter how weird it looks, even something like this. As long as I choose an input, doesn't matter what input I choose, I'm only going to get one output. For instance, in this one, if I chose y equals, or x equals 2, I'd say y equals 2 squared minus 3, 4 minus 3 equals 1. There's no way I'm going to correctly plug 2 into that equation and get something else. It's not until later on in maybe a later IM class where we're going to actually see equations that are not functions. We'll talk more about that later. For what I'm looking for here, you should have some kind of complete sentence. When in doubt, go back to the definition of a function. Every input gives you specifically one output. You never get 2 outputs from the same input. Here we're deciding if something is a function or not. If not, we have to say why. For A as an equation, as long as that equation always gives us one output for every input, which is pretty much any equation you've ever seen, we get to say, yes, that's a function. You could verify that if you wanted to by making a table. No matter what number you plug in, you're going to get a different number out. There's no way you're going to write down like the number 0 and get 2 different answers. Part B. For every house, there is one and only one street address. When they say street address, I assume they're talking about the number. For example, the address for this school is 1 Titan Way. Does that mean that this is the only address for this school? Yeah, the same place isn't going to have two different addresses. So for instance, maybe your house, call it house A, the address is 2173. Your address isn't going to also be 2174. That doesn't make sense. One house cannot have two different addresses. So yeah, this is a function. Take a look at this table. Again, for every input, we should have one output. If I look at my input -1, I only get one output. 0 is a little trickier. 0 goes to 0 and 0 goes to 4. Since I have one input going to two different outputs, I say no. For explaining my reasoning, I should be writing some kind of sentence saying that one of my inputs, 0, goes to two different outputs. So that's a problem, not a function. Don't just say no, you've got to put your reason in words. Part D, looking at the mapping, that's kind of the easiest one to decide because I can see right away that one of my inputs goes to two different outputs. So my answer is going to be no. And once again, I've got to write a complete sentence about the fact that my input 2 goes to two different outputs, 7 and 20. Part E, we've got ordered pairs. So it's time to find out if every input goes to one output. And it might be easier for you if you just draw a little mapping. I'd look at all my inputs, -7, -5, 2, and 3. -7 goes to specifically 5. -5 goes also to 5. But that's okay. Every input is still going to one output. I don't care if the two inputs go to the same output. That's totally allowed. 2 goes to -2, and 3 goes to 5. I don't care if everyone in the room points at 5. That's still a function because every input has one output. So that's a yes. And part F. The easiest way for me to check part F is try the vertical line test. That's the easiest way to do it with a graph. No matter where I put my vertical line, that vertical line only goes through the function one time. If there's anywhere that the vertical line goes through more than once, we say not a function because for that input, we had two outputs. In this particular picture, every input has one output. So yes, that's a function. The only one that wasn't a function, the only two that weren't functions were C and D. I should see sentences describing why. Draw an increasing function. There are an infinite number of good answers for this. Something simple, increasing function. I'll do another increasing function with green. Maybe I'm increasing curved and then kind of curve some more. That's still an increasing function. As long as the inputs are getting bigger and the outputs are also getting bigger, or in other words, going from left to right, it's going uphill, that's going to be increasing. Alternatively, a decreasing function is a function that's always going down from left to right. As the inputs get bigger, like from 0 to 2, as my inputs get bigger, my outputs get smaller. It doesn't have to be a straight line. You could have something that's going down, curvy. You couldn't have something like this, because that's a function that's increasing at first and then decreasing. So we don't want something like that curve of a shape. A constant function. There are multiple ways to draw a constant function, but they all kind of look the same. A constant function has to not go up or down. So it's going to do something like this. Now, You could have an infinite number of answers still because you might move it up, you might move it down. Anything like that is fine. What you can't do is this. You cannot have increasing, you can't have decreasing. It's got to be flat, no ups, no downs. For this one, you should have typed in 3x minus 5 into Desmos. You should have had something just like this on your screen. If you don't, go back and fix it. For this one, you should have typed 2 times 3 to the x minus 4. If you had trouble typing that exponent of x, the way you can do that is on Desmos, find the little exponent button. So I open up Desmos, and I pull up my little keyboard. I want to type 2 times 3 to the x. So I'll press the 2 key, that's easy, times 3. Now to get that exponent, if you look down on the keyboard where you see that little a and b as an exponent, it's to the left of the 7 on my screen. If you push that button, it's going to give you a little exponent spot. Then you can type x. Notice we're still in the we want to get that exponent, we want to get down out of the exponent, so you can use your left arrow, your right arrow. Once you get down, you can type your minus 4, and you'll get your graph. This next graph that you should have put into Desmos has one extra little step at the end. You're supposed to decide if you have an absolute maximum or an absolute minimum. I know I have an absolute minimum because there is a lowest point on this graph. Lowest should remind you of the word minimum. So since I have a lowest point, I should have typed in absolute minimum. This one, I type it in the Desmos. I'll show you how to do that in a moment. And I also have to decide absolute maximum or absolute minimum. Since there is a highest point, I should have put something like absolute maximum. Now let's take a look at how you would type that into Desmos. I gave one tip on how to find that absolute value button on your keyboard. You can also go straight to this Desmos keyboard and type y equals -1. Now, for absolute value, notice that little functions button in the bottom right corner. I tap that, and I'm on the MISC tab. I think it starts you over here on the trig tab. You'll have to choose the MISC tab, and ABS stands for absolute value. Notice it put ABS up on my screen. I can now type the rest of my expression in those parentheses. Inside the parentheses, I'm going to go inside the parentheses, I'm going to say, I believe, x plus 2. X plus 2. And then plus 3. Alternatively, we could have also written y equals -1. And if you look over on the far left of your keyboard up on the screen, you've got that little absolute value of a button. It's going to give you the pretty little absolute value bars. This works too. Now I can type x plus 2, get outside of those absolute value bars, plus 3. And as I turn that guy on and off, you can see that the green and the orange are right on top of each other. These are both totally valid ways to sketch this graph. I don't have a whole lot to say about this one, but go back and check your work. Make sure you match the correct vocabulary to the correct statements. You can pause the video. When you're done, you can move on. All right, we're looking for an axis of symmetry. Axis of symmetry, if you recall, is a vertical or horizontal line that cuts the function in half and treats it like kind of a mirror. This first graph does have a vertical axis of symmetry. Looks like it might be around negative, not quite -1, maybe -0.8, kind of hard to tell. So my axis of symmetry might be x equals -0.8. I don't have a horizontal axis of symmetry on this problem because nowhere on this graph can I put a horizontal line and have the graph look the same on both sides. You also have to say how many quadrants this passes through. Let's remember what a quadrant is. There are 4 quadrants on a graph. We've got quadrant 1, two, 3, and 4. I can see that this graph crosses through all 4 quadrants, so I'm going to say that this graph passes through 4 quadrants, all 4 of them. Let's look at part B on the quadrants before we talk about axis of symmetry. I'm assuming that this line goes off forever this way and off for this way. If I use the same colors as part A, that green quadrant, which is quadrant 2, definitely have part of the graph there. The blue, I definitely have part of the graph there. That's quadrant 3. The purple, I also have part of the graph. But notice quadrant 1, the graph never seems to go over there. So we're only in 3 quadrants. And if you want to be more specific, you can even say it's quadrants 2, 3, and 4. If you don't remember, the quadrants are numbered like so. Let's talk about axis of symmetry. If I go put a vertical line anywhere here, it doesn't look like it's going to look like a mirror. It doesn't look the same on both sides of that vertical line. So no vertical axis of symmetry. Let's try horizontal. No matter where I put this horizontal line, it does not look like it's operating like a mirror. So identify the axis of symmetry. It's as simple as saying no axis of symmetry. Last up, 2 algebra problems. I know these are kind of hard. If you didn't quite get it right, try to see the steps. Make sure that you understand why I'm doing what I'm doing in the steps. A reminder, you should be showing all of your work in your spiral notebook. There's no way I can do this in my head, so I'm not going to buy it if you say you did it in your head either. You got to show your work on this kind of stuff. Start by distributing. 2 times 9n is 18n. 2 times -6 is -12. Plus 52 equals, time to distribute again. 2 times 7n, 14n. Plus 2 times 8, plus 16. Lots of stuff to do on this problem still. First, I'll collect some like terms, working on one side of the equal sign. -12 and +52. You should be able to do this without a calculator. I notice the signs are different, a negative and a positive. So the way I think about this is I lost $12, I gained $52. Since I gained more than I lost, I know that overall I've gained. And I know I must have gained less than 52 if I lost 12. So I'm not going to add those 2 numbers together, I'm going to subtract. 52 minus 12, 40. Still have the 18n, no like terms over here. Next, I notice I have n on both sides. I can either minus 18n from both sides or minus 14n. I'm choosing to minus 14n because I like to avoid negative numbers if possible. And I know 18 minus 14 is not going to give me a negative number. It's going to give me a positive 4n plus 40 equals 16. 2 more steps on this problem. I've got to get that n by itself. So the next thing I'm going to do is get rid of the 40. Opposite of plus 40 is minus 40. Be careful here. Don't use a calculator. You're expected to do this without a calculator. I'm going to think of the money analogy again. I've got $16. I've got negative $40. Overall, I lost more money than I gained. So I want to find out how much I lost. I didn't lose $40 overall. I should have less than $40 that I lost. So the way I'm going to figure that out is I'm going to go 40 minus 16. I don't want to add those two numbers together because the signs are different. I subtract those. I have to borrow. 10 minus 6 is 4. 3 minus 1 is 2. So overall, 24. But be careful. We lost more than we gained. So if you just write 24, you made a sign mistake. We lost more than we gained. All that's left now, get that m by itself by dividing both sides by 4. We get negative 6. That's it. Last question. I think this one's a little easier than the other one because we don't have to solve for anything. We just have to plug numbers in. So let's do that carefully and deliberately, keeping in mind the order of operations. Reminder, order of operations. A lot of you know PEMDAS. Be careful because the M and D get equal priority. Multiplication does not come before division. They happen at the same time, left to right. Same thing with addition and subtraction. They get equal priority. You don't add before you subtract. You do both equally from left to right. Of course, our first step is we've got to plug numbers in. I've got to change all my x's to 8s and all my y's to 2s, negative 2s. So 3, 8 squared minus 8, negative 2 plus 2, all over 2 times negative 2. So order of operations says deal with parentheses first. I see an 8 in parentheses, but there's nothing I can do to it. So I leave it that way. Negative 2 plus 2, on the other hand, I can do something with that. Negative 2 plus 2 is 0. So I can write my next step out and go 3 times 8 squared minus 8 times 0, all over 2 times negative 2. Next on the order of operation is the E for exponents. I only see one exponent. 8 squared is 64. So I'm showing all my work here. Some of you might be able to skip ahead a little bit because you see some stuff. Next, multiply and divide, equal priority, left to right. 3 times 64, work it off by on the side if you have to. You should not be using a calculator. 3 times 64 is, I believe, 192. 8 times 0 is 0. 2 times negative 2 is negative 4. Next, I notice the top and bottom of the fractions. I could do something on the top, but not the bottom. Think of that as an extra set of parentheses. Now that I've simplified everything I could up top, it's time to take it one step further. 192 minus 0 is 192, divided by negative 4. Again, do not use a calculator. You can set up a division problem. You can figure out how many times 4 goes into 192. 4 goes into 1? Nope. 4 goes into 19 4 times. 4 times 4 is 16. Subtract. 4 goes into 32 8 times. So if you go ahead and say 48 is your final answer, you made a small mistake. Don't forget your signs. Positive divided by a negative is definitely a negative. And that's it. I know today was a long lesson. We can persevere. We'll get through this together. Be sure to fill out your last 2 slides, especially where you tell me, I believe in one, it's asking you to tell me what you learned in this lesson. Be specific. And more importantly, for feedback to me, be sure to let me know any questions you still have about any of this content. Thank you so much, and stay savvy, my Padawans.